Welcome back to another video. Today we're going to be going over how to add collisions to our enemies. So we're going to take our little stomp guy over here, we're going to add a collider to him, and whenever the player collides with him, we're going to restart the level. And we're also going to do that for the spikes. And after that, we are going to add a chest, and we are going to add a win condition. So when you reach the chest, then the level will continue on to the next one. Or in this case, it will just restart this level since we only have one level. So let's get started. The first thing we want to do is add a collider to the enemies. So in our hierarchy on the left, we want to go under our environment game object and select the enemy. So we can just click on the enemy and it'll select it, which is the mace right now. And all we have to do to add a collider is on the right under the inspector, we add component, and then we add a 2D box collider. And so this automatically calculates the bounds of this enemy and adds a collider to it. And then for our spikes, we're going to want to do the same thing. So we can click the spikes, and in this case, we want to have one collider for both spikes. So to do that, we can just under environment, we can right click environment, and then we can create an empty object. And then we can click these two game objects, the spikes. So click one and then press Control and click the other. And then we can just drag them under the new game object, dragging them onto the game object. And so then we can rename the game object by pressing F2, and let's rename it to spikes. And so one thing we want to do before we add a box collider to the parent is that we want to copy the transform of the child. So let's go to one of the childs, let's copy that transform. So right click, copy component, and then let's copy that onto its parent transform. And the reason we want to do this is that we want to center the parent wherever the children were previously, and that's to make sure our collider is centered in that spot. And now our spikes have moved because it moves according to our parent. So since our parent location was moved, our children location moved. So to center that, all we have to do is press 0 and 0 on the X and Y for both spikes. And now they are centered where they were previously. And since now they're in the same spot, let's select one of them and move them to the side by clicking and dragging, or you can change the values in the transform directly. Cool, now since we have our parent now, in our parent we can add a component, and let's add a box collider 2D. And so this is useful if you have a bunch of spikes and you don't want to add a collider to each one of them. You can make them a child of a parent, and then the parent can have that box collider, and you can change the size of the box collider as you need to. So as you can see, the box collider is not looking correct, so we can change the size by adjusting the X. So let's just put it to 1.25. Let's change the Y size to maybe 0.5. And then let's change the X offset to 0.25. So if the player lands on that area, then the player will have to restart the level, which we're going to write in a short second. So now let's go to our player script. So under assets and then scripts, let's click our player controller. And then Unity has a built-in function. If we scroll all the way down, we can add a new function. And that function is going to be called onCollisionEnter 2D. So if you type it out, Unity will autofill it for you. And it's called onCollisionEnter 2D, and it takes a collision 2D component. So this is attached to our player, and our player has a rigid body component and a box collider component. So whenever our collider collides with another collider, so in this case, whenever our player collides with an enemy, then Unity will automatically execute this function. So this is useful to say if we crash into the enemy when we want to restart the level, we would do it in this function. But how do we know if we crashed into an enemy? Well, in Unity, there's things called tags. So you can tag game objects. So if we go back to our editor and then we click on the enemies, we can click on the mace and we can click on the spikes, which I just realized I spelled incorrectly. Let me just change that. So if we click on these two game objects, we can select both of them. And then under the tag, we can add a tag, plus button, and let's add in an enemy tag. So tags are useful when you want to identify a group of objects together. So in this case, enemy would be a great tag to identify all of the enemies. You can also have sub tags. So if you want to have a tag under enemies, you're allowed to do that. And this is useful because, as you can see, if you did it through the name instead, the names are different. You'd have to check each name manually if you had different names for different enemies. But since you have one tag for all enemies, you can just check if the collision is with an enemy tag, and if it is, then you restart the level. And so you want to make sure that the tags are in the game object with the collider. So we can click the spikes and we can click the mace, and then under tag we can click enemy. And that's because we collide with this collider, this box collider 2D, and then it will check this game object's tag, so it will check this tag and it will be enemy. So now let's go back to our player controller script, and we can check if that tag is equal to the one we want to check, enemy. So if other.gameObject.tag equals enemy. So this is a comparison if our tag is equal to the enemy string, then we will load in a new scene. To do that, we have to import a namespace. So at the top, we go to using Unity Engine.scene management. And to do that, we can access our scenes. So to load a new scene, we just do scene manager.load scene. And then we can load in our current level, which in this case, we can do that by doing scene manager dot get active scene, and then we can do dot build index. And so let me show you how this works. So let's minimize this. And in Unity, every scene has a build index. So currently we are in one scene. If we go to our assets and then we click on our scenes, you can see that we're in this sample scene. And scenes are useful if you want to have multiple levels. You'd have multiple scenes and each level would be in a separate scene. And then to add in a scene to your build, all you would have to do is go to File, Build Settings, and then in Scenes to Build, you would add Open Scenes. So any scenes that are not in this Scenes to Build will not be included in the build. And the build is just an exe in this case. So now that we added our scene to the build, you can see that on the right, there's a little index. So currently it's the 0th index because it's the first one. And in coding, you start with the 0 instead of 1. So you could have just put 0 here, but if you wanted to make this adaptable to different levels, you can just get the current active scene and refresh it. So now if we click play and we run into the enemy, we will start the level over again. There we go. And so one thing that I want to add to make this a little more interesting is that on this enemy specifically, I want it to be moving up and down. So kind of like in Mario. And to do that, we can go to Assets, we can go to Scripts, and then I can right click and create a new C# script, and we can call that enemy mace. And then we can attach that C# script to our enemy. So we click on our mace in our hierarchy, and then we can add component enemy mace. So now we can double click that script, and let's add in a small command to make it move up and down. So first we want to store its current position, so its starting position, and it will move relative to its starting position. So in the start function, we just put start position equals transform.position. So this is just keeping track of the current position. And in the update function, we can set the current position of the game object. So transform.position equals, we take the starting position, which is starting position, plus, so we're adding two vectors here, and we're going to make a new vector 3. And we only want it to move up and down, so in the X, we're going to put 0. And for the Y, there's actually a nice wave called a sine wave that moves up and down with time. So Unity has a mathf.sine, and then we can just pass in the current time, which you can get by time.time. So that's the time since the beginning of the frame or the start of the game. And then we add in a 0 for the z-axis. So pretty simple. So now if we click play, you can see our enemy is moving up and down. It's pretty cool. And so if you want to make the mace go a little higher, we can actually multiply this by 2. So that's the amplitude of the sine wave. So now it'll go up and down a larger distance. Now you can see it goes up and down further, so we have more time to go under it. And our spikes are pretty small, so we can just quickly adjust the size of the spikes. Oh, that's because in the parent, since we copied the transform, it also copied the scale, so we can just set the scale back to 1, 1 on the X and Y. And so now it looks normal again. And so another cool thing you can do in Unity is called a prefab, and a prefab basically saves your properties of a current game object. So if you want to copy that game object again, you can just literally drag it onto your scene. So this is useful if you have a lot of game objects with the same properties and you don't want to be copying and pasting all the time, or manually putting in the properties each time. That can be a little hectic. So to do that, we can just make on our assets, we can create a new folder and we can call it Prefabs. And then to create a prefab, all you have to do is grab the game object you want to make a prefab of. So in this case, we can click the mace, then we can drag it into the prefabs folder, and it will automatically create a prefab for us. So then to show you how this would affect the gameplay, we can go to our enemy mace script, and we can make a serialized field of a private int amplitude. And let's equal that to 2 to start off. So let's copy that amplitude and let's just replace the 2 in our update function with the amplitude variable. So now we can change it in the inspector depending on how high we want each mace to go. So if we click our mace, you can see our amplitude is 2 now. And now we can actually click our mace in our prefabs. We can drop it onto our scene. And currently it's not under our environment game object, so let's just drop it under our environment game object. And it's not rendering correctly, so let's actually put the order in layer to 1. Now let's do that for the other mace because we don't want it to affect the rendering. And here in our second mace, we can actually change the amplitude to maybe 1.5 to make it a little harder for the player to pass. But to do that, we actually need to make the amplitude a float, since integers cannot have decimals, so let's just make that a float. And now we can put in 1.5 for the amplitude. 1.5. And now when we click play, see this one goes faster down than the other one. And now you have to kind of time yourself here so you don't accidentally die. Awesome, and now let's add in a chest. So we can go in our assets, we can go to Bayit Games, free platform game assets, chests, chest, PNG, sheet, and then here are different chests that we can use. Let's just use the second one, which is basically they're just different sizes. And now all we have to do is click multiple, since this has multiple sprites. We click apply, we go to our sprite editor, we press slice, slice. And now each of our chests are sliced automatically. We click apply on the top. And now if we click the little arrow next to our second chest, we have all of our chests sliced. So we can click the first one, press shift, click the last one, and then we right click, create, animation, and we can call this chest open. And we can drag that into our animations folder under our assets. So let's add in a chest. So let's go back to that chest folder and let's select the closed chest. We can actually drag that onto our scene. Right now it's huge though. Let's drag it over here and let's set that size to 0.25 and 0.25 and drag it to the bottom. Let's rename this chest, and then as we went over before, to add our animations, we can add a component and we can add in a animator component. And then we can go to our animations folder under assets. And here's our animation. But to do that, we need an animator. So we can right click, create, animator controller, and we can call this chest. So this is the animator controller for the chest. We can double click it. And then all we have to do is drag in that chest animation. But currently it's set as the default animation, so right when we start the game, it's gonna open, and we don't want that. So on the parameters list, we're gonna set a trigger open. So whenever we trigger this open variable, then it will go to open. But first we need a default animation, so we can quite literally go back to our previous folder. We can grab the first image, which is the separated one, and then we can right-click create animation, and we can call that closed chest. And once again, drag that onto our animations folder, and we can just drag that closed chest onto our animator. And then we can right-click closed chest, set as layer default state. So this is the default. And then we can right-click make transition to chest open. And then when you click the little arrow, then under conditions, we can add a new condition and it will do it on the open condition. Cool. So now to trigger this, we can go back to our scene, we can click our chest, and we can add in a script to trigger this. So we can add a component, we can add in a new script, and we can call this script win. And it will automatically add this script to this game object. But how do we know if the player actually collides with this chest? Well, all we have to do in this case would add in a box collider 2D. So now the player would know if it collides with the chest, and the chest would know if it collides with the player. However, we don't want this to be a normal collision, we want this to be a trigger. And so under our box collider 2D, you're gonna see there's an IsTrigger parameter, and we're gonna select that. And so why would we use IsTrigger instead of a normal collider? Well, if we go to IsTrigger, documentation for Unity, it says a trigger doesn't register a collision with an incoming rigid body. So the player would still be able to pass through the chest. The chest wouldn't stop the player from passing, like a wall would where you would have a normal collider. And that's the big difference with a trigger. It can let the object colliding with it pass it. And this is useful if you want to have checkpoints through a level and you don't want the checkpoints to be visible. So in a 3D game, you would have two poles and you would want to have kind of like a goal. So once you pass those two poles, it would trigger the checkpoint. So in that case, you would put IsTrigger because you still want the player to pass that checkpoint, but you also want to know when they pass that checkpoint. Let's click on our win script. So let's right click, edit script, and then we can erase this. Then we can put on trigger enter 2D since we're using 2D collider. Then you can put if other dot tag equals player. Then we can get our component animator. So we get our animator component and then we set the trigger open. So it will set that trigger. And now we have to make sure that our player is tagged as player. So if we minimize that and we go back to our player, and so Unity already has a player tag for us, so all you have to do is under tag, we just click player. And before we play the game, I remembered that we never actually set the animator for the chest, so we can just click under the animator component, we can click this little circle on the right, and then we can just click on chest. And now let's click play. So when we reach the end, then the chest will open. And so one thing that I forgot was that I was using a wrong image for our closed. So if we click our chest, under our sprite, I actually went back to the Bayat Games folder, the chest folder, under the sheet folder. Then I actually used the first one, sprite that we split, and then I just dragged it onto our chest. And so that fixes that weird issue where it went up. And now we're almost done. Stay with me, guys. Now, when we reach our end, we want to change our level after the chest has opened. So, luckily, in our animator component, under our chest component, Unity implemented a behaviors in our animator. So we can add a new behavior, we can add a new script, and then we can name that script chest behavior. create and add. And so then now we have our script attached to that state. And then we can edit the script by right-clicking it. And we have a bunch of stuff here. We have onState enter, onState update, onState exit, and this is the one we want. So let's select these two and let's uncomment them. I'm on Visual Code, so I can just uncomment them with Control/, but on Visual Studio there might be another command to do it all again, or you can just erase them manually. So this is when the state exits. So when the animation stops playing, then we want to switch our scene. So up here we can say using Unity Engine .scene management, and then on state exit we can do scene manager .load scene, and then you can say scene manager .get active scene .build index. If you wanted to go to the next scene, you would do +1, but since we only have one scene, let's just restart the scene when we win. Now let's click play, and voila, we have our little game. So let's wait until these little guys go up, and then we can make our way. Woo! We jump, the chest opens, and nothing happens. And so the reason nothing happens is that I just realized that I made a silly mistake. So since we don't actually have any transitions going out from chest open, then that state never finishes. So all we would have to do is click make transition, and we just make a transition to the closed chest. It doesn't actually do anything, but we need it because it will transition once this one is done, the chest open. So once chest open is done, it'll transition back to the closed chest, meaning the state has an exit condition. So if we click play, then we have our MMORPG VR procedurally generated game that has top of the line physics and dynamic lighting, and it works. So thank you so much for watching. In the next video, we are going to be adding sound. And after that, I'm going to be showing you how to build your game and publish it on Unity's website. So thanks for watching and see you next time.